Okay, so did anybody have questions from the review that you guys wanted to go through?
Is there gonna be domain and range on the test?
I haven't made the test yet, but I'm anticipating yes. I didn't put it on the quiz, but I am going to have it on the test.
Alright.
Can we do number 5?
What? Okay. So number 5, the first thing you do is you start by factoring both the numerator and the denominator. And you notice I threw one in there that has 4 terms. And so when you're factoring with 4 terms, you have to factor by grouping. So for the first, or for the numerator, to factor that, I would take out an x squared. I'm left with x plus 5. Then I take out a negative 4, x plus 5. So I end up getting x squared minus 4, x plus 5, which I then know, I'm gonna have to give myself some more room, which then from there, I can factor that again to be x plus 2, x minus 2, x plus 5. On the denominator, I factor by grouping. I pull out an x squared, I'm left with x plus 2, minus 1, x plus 2. So you end up getting x squared minus 1, which then that factors, that's also a difference of squares, to be x plus 1, x minus 1, and then x plus 2. So from there, I then see if I can cancel anything out, which I can. The x plus 2's will then cancel, and that means that I have a whole at negative 2. And I'm left over with x minus 2, x plus 5 over x plus 1, x minus 1. When I plug in negative 2 in for x into my new equation, I end up getting negative 4 times 3 over negative 1 times negative 3.
Wait, how did you get that?
I plugged in negative 2 for all of these x's.
Is that how you find a whole?
That's how you find the y value of the whole. The x value I found by setting the factors that I canceled equal to 0. So the x plus 2 is canceled, so that means I have a whole at negative 2.
Okay.
And then to find the y value, I have to plug that in to get the y value. So if I end up simplifying this, I get negative 12 over 4, which would then be negative 3. So my whole is at negative 2, negative 3, which is right here. Then I start filling out all the things that I have. So my vertical asymptotes, I would have one at negative 1 and positive 1. I can go ahead and draw that. Then I look at the degrees. The degrees are the same. They're both x squareds. So that means that I'm dividing the coefficients, and then there's nothing in front. So my horizontal asymptote would be at y equals 1. My x-intercepts, I'm setting the numerator equal to 0. So I have 2 of them, one at 2, 0, and one at negative 5, 0. So plot there and here. And then my y-intercept, I am setting x equal to 0. So if I plug in 0 for x, I end up getting negative 2 times 5 over 1 times negative 1, which is 10, which is all the way up here and it ran out of room. So then I can connect the dots, which this is going down. This is here. And then this would be going away. And we know that it doesn't point down because we don't have any more x-intercepts. So I don't have to test points here because if it were going down, that would mean that it would have to cross the x-axis, which would then mean I would have more x-intercepts than just those two. So I know that it's going away from the x-axis.
If we did need to test points, can you just, you don't have to write it down or anything, but can you just explain how to do that one more time?
If I needed to test points in this case, I would need to put two x values in that were in between -1 and 1, like in between 0 and -1 and 0 and +1. Because
So you would plug the number into your like equation that you have, like
exactly,
X minus X
I'd
plus
plug it into this one.
Okay.
Then for domain and range, you're only stopping at holes and at asymptotes, okay? And at the end of it, it's always going to start at -infinity and go all the way to +infinity. So I start all the way to the left, -infinity. I stop at this hole right here, and I want the x value of the hole, which is -2. So I've stopped there. Then I start up again at -2, and I keep going until I hit an asymptote, which would be at -1. This is a long one. Then I start up again at the asymptote, and I go until I hit another asymptote, which is 1. Then I start up again at 1, and there's no holes or anything, and I go to +infinity. With the range, I'm reading it from bottom to top, and I only stop at holes and asymptotes. So I start at -infinity, and then I stop at this hole right here. But I want the y value of the hole, which we already found the y value is -3. Then I start again at -3, and I keep going until I hit the horizontal asymptote, which is at 1. And then I don't start up again at 1. There's actually nothing between 1 and my y-intercept, so I don't need to put anything there because there's no part of the graph that's there. It doesn't start up again until 10, and then it goes to +infinity. So you just have to look and see where on the graph is there actually a function or where is it defined. Okay, what other questions do you guys have?
Can you explain slant asymptote, like what I'm supposed to do?
So there's two questions that have a slant asymptote. The first one is number 4, or no, it's not. The first one is number 2. And I'm not going to go through the whole problem, but I will explain the slant asymptote part of it. So on number 2, I know there's going to be a slant asymptote because I have a higher degree on top than I do on the bottom. So that means there's no horizontal asymptote, there's just a slant because it's a bigger degree on top. To find your slant asymptote, there's two ways. It's either long division or it's synthetic. And synthetic is the easier one, right? It's the one that's more fun to do. I know that I can do synthetic when my degree on the bottom is just 1, like x. If I have an x squared on the bottom, I cannot do synthetic division. I have to do long division, which we'll look at number 4 here in a second. So since I have just an x on the bottom, that means that I can take my denominator, set it equal to 0, and the 4 goes in the box. Then my numerator coefficients are what I put on top. So I have 1x squared plus 0x minus 25. And so since it skipped the x, I just put a 0 in its place. Then to do synthetic division, I bring the first number down, and then I multiply. So I take 4 times 1, which is 4, and then I add down. 0 plus 4 is 4. 4 times 4 is 16. I add down, I get negative 9. And that's my remainder. But in slant asymptotes, I don't care about the remainder. So my slant asymptote, or the equation of this line right here, is y equals x plus 4. Because I've divided 1 degree. So I have 1 degree less. This is x, and then this is the constant. And then on the graph, I would then just plot or graph like I would y equals mx plus b. So it would technically have, you know, a y-intercept at 4, and I would have a dashed line, just like that. However, on number 4, I have a bigger degree on top than I do on the bottom. So I know I have a slant asymptote, but I can't do synthetic division because of this x squared. So since there's an x squared on the bottom, I have to do long division. So I would put x squared minus 1 to the left, and then underneath the box, I'm going to put x cubed plus 3x squared plus 0x plus 0. So I put zeros in the places that I've skipped a degree. Then I look at it and I think, how do I get from x squared to x cubed? I have to multiply it by x, so I put an x on top. Then I distribute that x to the x squared and to the 1. So I get x cubed minus x. And notice that when I multiply the negative 1 and the x, it's going to go under the 0x. It wouldn't make sense to go under the x squared because they're different degrees. Then I flip my sign. This becomes a minus, this becomes a plus. And I add down. So this 3x squared comes down plus x plus 0. Then I do it one more time. To get from x squared to 3x squared, it would be plus 3. And I distribute 3x squared minus 3, flip the signs. X plus 3 is my remainder. And I know that that's my remainder because I can't make x squared become x. The degree is 1 smaller. So I don't need my remainder at all. I know that I'm done when the last thing that I put in is a constant. So my slant asymptote would be y equals x plus 3. And this would not matter. And then I graph it the same way that I did in number 2. So does that help answer your question?
Yes.
Okay.
So basically, you have a slant asymptote if it's bigger on the top, right?
Yes.
So every time it's bigger on the top, you have a slant asymptote.
Yes.
Okay.
Can we go over number 14?
Uh-huh. Okay, number 14. So it automatically has one of those number minus x kind of things. So anytime I see that, I go ahead and cross it out and I change it to be minus or negative x minus 5. And remember that negative, it doesn't matter where it goes. It could go on the top, it could go on the bottom, it could go out front, but either way, it means the same thing. So for me, I might just want to put it in front of the top. I just kind of like having the negative on top for some reason. Then after I've done that, I highlight or circle all of my denominators, and this is a complex fraction problem. So I find the common denominator and I multiply it by all 4 of the fractions. So my common denominator in this problem would be x minus 5. And so I multiply that by every single fraction, all four, and then I write whatever is left over. So if I multiply the first fraction by x plus 5, x minus 5, the x minus 5's cancel, and I'm just left with negative 4x. The second one, the x minus 5's cancel, and I'm left with 5x. On the denominator, the x's will cancel, and I have 2x minus 5. And then the bottom right, the x minus 5's cancel, and I have 3x. Now I could go ahead and change this to be 2x minus 10, just so that now it's easier to simplify. The top, the negative 4x plus 5x just combined to be x. And then on the bottom, 5x minus 10, which I can then continue to simplify by pulling out the 5. And then I would be done.
Thank you.
You're welcome. Okay, what else?
Can you do number 10? I'm sorry.
Number 10. Okay, number 10 is an addition problem. So I need to factor the denominators and find a common denominator. So factoring the bottom left is plus 2 plus 5x plus 2 and x plus 2. And then factoring the bottom right would be x minus 3, x plus 2. So my common denominator would be 5x plus 2, x plus 2, x minus 3. So I'm going to go ahead and write that really big as one big fraction. Then I look at the first fraction and I decide, well, what am I missing? I'm missing an x minus 3. And so if I factor those, it's actually a difference of squares, and it becomes x squared minus 9 plus what's missing from this fraction is a 5x plus 2. So if I distribute that, I get 30x plus 12. And then once I have that, my final step is to simplify the numerator. So all I can really do is combine the negative 9 and the 12. Like that. And leave the bottom as is. And then I look and see, is there anything I can do on the top? I can't factor it, so I'm finished.
So when would you have to use the quadratic formula?
Only when you're, so this question is just an adding, subtracting. There's no equal sign. So I only would need to use the quadratic formula when I'm solving.
Can you not put that on the test?
The quadratic formula
Yeah.
could be on the test.
Well, I'd appreciate
Just
it.
don't use it unless you're solving. So on adding and subtracting questions, like everything from, I think I put them all in order. Everything from 9 to 12, those are just adding, subtracting questions. So your answer should have a denominator. There should be an x in your answer. Then 15 through 20, or not 15, 16 through 20, all of those have equal signs. So that then you should get an answer like x equals something. So if it has an equal sign, I'm going to ask you to solve, and that's when you could potentially do the quadratic formula. But
Can you solve 18?
Okay, number 18. I need to find a common denominator first. And the common denominator would be 3x, x plus 4. The second thing I need to do is find my domain restrictions. So neither of those, like the 3x or the x plus 4, could equal 0. So x cannot equal 0 when I set 3x equal to 0, and x could not equal negative 4 when I set the negative, or x plus 4 equal to 0. Then I take all three of my fractions and I multiply, I multiply by 3x, x plus 4. You can write it above every fraction if that helps you, or you can just do it mentally. Doesn't matter. On the first fraction, everything cancels and I just have 12. On the 1, there's no fraction, it's just a 1, so I just have 3x, x plus 4. And then on the last fraction, the x plus 4's cancel, and I'm just left with minus 3x, because there's that minus out in front. Then I can distribute the 3x. So 3x squared plus 12x minus 3x, which becomes plus 9x. When I get to this point, I then want to move everything to one side and then factor and solve it. So, or if I can't factor it, that's when I'd have to use the quadratic formula. So I'm going to move this 12 over to look like this. And they all have a 3 in common, so I can pull out a 3. I'm going to come over here. And I have x squared plus 3x minus 4 equals 0. Then I can factor it. So it'd factor to be x plus 4, x minus 3. Then I set each parenthesis equal to 0. Now this 3 really doesn't matter because there's no x connected with it. If I also pulled out an x, then I would have x equals 0 as one of my answers. But if it's just a number out front, then I don't even worry about it. I don't even look at it when I'm solving. So I have two answers, x equals negative 4 and x equals 3. But, and this showed up on your quiz actually, since this is a negative 4 and this is a negative 4, it's one of my domain restrictions. So I don't count that one. I just cross it out and I only have one answer, which would be at x equals 3.
Wait, how do you figure out if you can't use a number again?
If it's one of your domain restrictions, which you found by setting your denominators equal to 0 in the original problem.
How do you set 3x squared plus 12x to 0?
I factored it first and then I set each part equal to 0. Okay, what other questions do you guys have?
Is there a question that on the review that we have to use a quadratic formula for?
No, I didn't put one on there.
Can you please solve 15?
Uh-huh. Okay. 15 is a complex fraction question, but since it's like fraction, 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 and it doesn't look like let's say 13 or 14 where you have these minuses in between. So like number 14, I would consider to be like 4 separate fractions. 13 would be like 3 separate fractions because you have this minus sign. 15 is different because it's truly like a fraction on top of a fraction. There's no plus or minuses outside of the fractions. So I can take this and I can take the bottom fraction and flip it and multiply. So I could rewrite this as times 6x cubed minus 6x squared over x squared minus 4. So I flipped it, and now I can multiply. So what I want to do is factor each component, top left, top right, bottom left, bottom right. When I factor, the hardest part about these, like this kind of question, is it's not difficult, it's just hard keeping organized. So I just would suggest, like, don't try to bunch up your work, try to space it all out so that you're really organized with what factors you have. So the top left would factor to be x plus 3, x minus 2. The bottom right, or I'm sorry, bottom left, you could take out a 2x, and you would be left with x minus 2. No, you wouldn't. X minus 1. On the top right, you could take out a 6x squared, and you'd be left with x minus 1. And then on the bottom right, you could factor that to be x plus 2, x minus 2. Then it comes to the part where you cancel. So you can cancel diagonally, or you can cancel on top of each other, one on top of each other. So the x minus 2's cancel. The x minus 1's cancel. The 6 and the 2 reduced to just be a 3 on top. And the x squared and the x reduced to just be an x. So then I circle what all is left over, and that leaves me with 3x, x plus 3 over x plus 2.
This might be a not good question, but so you can cancel on top of each other and across, but you can't cancel like side by side, right?
Right. You couldn't cancel side by side. So if I had like another x plus 3 out here, then I would just have to write x plus 3 squared. I could not cancel those.
Okay.
That was a good question.
Oh, sorry.
Okay, what else?
Can you do 13?
Uh-huh. Okay, 13 is another complex fraction question. I'm gonna circle all of my denominators, or highlight them, and find my common denominator, which would be x, y combined. And then I take x, y, and I multiply it by all of my fractions. This is only one fraction, it's not two. I have 3 separate fractions, 2 on the bottom and then just 1 on top. So when I multiply the first fraction by xy, the top and the bottom, numerator, denominator cancel, and I'm left with 4x squared minus y squared. When I multiply the bottom left fraction by xy, the y's cancel, and I'm left with 2x. And then bottom right, the x's cancel, and I'm left with just y, 2x minus y. You look at that and you think, am I done? And the answer is no, because technically I can still factor the top. It's a difference of squares. It just has a y in it instead of a number being right there, because we're just used to x's and numbers. But I could factor this to be 2x plus y, 2x minus y, because these are both squares. If I square root both of them, 2x and then y, over 2x minus y. So then these cancel, and my final answer is just 2x plus y. Okay, what else?
Could you do number 6?
Mm-hmm. Okay, number 6. I have to zoom way out. So number 6, I can factor the denominator to be 4x over, if I take out an x, I'm left with x squared minus 9, but I'm just gonna go ahead and factor that to be x plus 3, x minus 3 in one step. Then I look and see if I can cancel anything, which I can. The x's cancel, which then tells me that I have a whole at 0. If it's just an x that cancels, the whole is at 0. So then I'm left over with, let me just give myself some room. I'm left over with 4 over x plus 3, x minus 3. When I plug in 0 for x to find my y value of the whole, it becomes 4 over negative 9. So negative 4 over 9 would be my y value. And I got that by plugging in 0 for x. My vertical asymptote set the denominators equal to 0, so 2, negative 3, positive 3. Since I have a bigger degree on bottom, that means I have a horizontal asymptote at y equals 0, because the degree is bigger on bottom. X-intercepts, I set the numerator equal to 0. Well, that ends up being 4 equals 0, which doesn't even make sense. So that means none. I don't have any x-intercepts. If it's just a number on top, then I have none. X-intercepts, no x-intercepts. Y-intercepts, if you plug in 0 for x, you end up getting this 0 over negative 4 over 9. But that's my whole. So I can't have a y-intercept and a whole in the same place. So you can either write it out and then cross through it. I think that's what I did on the key. Or you can just say none. It's up to you. So then when I get to the point of graphing it, I'm going to scroll down a little bit. Whoops. So when I get to the point of graphing it, all I really have is this whole at 0, negative 4 over 9. And then these vertical and horizontal asymptotes. So I have nothing else that I can graph on here. I've got no idea what's going on. And this is the point where I would have to test points. Now my gut tells me like what I would think would be happening. I know this has to point down because I don't have any x-intercepts. So there's nothing that's going to pass through to go up. So I know that the middle part has to go down, which then probably tells me that these are going to be right here away from the middle. But I also want you to feel confident in your answer. So just to be sure, we can test some points. So I'm going to test negative 5 and 5. Just to be sure that I know that they're positive or that they're above 0. So my original problem is this. If I plug in negative 5, I have positive on top for both of them, obviously. On the bottom, if I plug in negative 5, I get negative times a negative, which ends up being positive. So positive over positive is positive. When I plug in positive 5, I end up getting positive times positive, which is positive, overall positive. So that just confirms my hypothesis that they were both above 0. If you wanted to be sure about the middle parts too, like just to be 100% sure, you could test any points here and here. So I could have tested -1 and +1 if I wanted to. And those would both tell me that they're negative. Okay, what else? Anything else?
Not for me.
Anybody else?
Can you actually go over number 4, please?
Uh-huh. Sorry, I'm making y'all miss all school worship.
Yeah, I
If
think
you
I
want
have
to
to
go to that,
Yeah, I have to.
you can get out now, and I'm going to have this recorded. So I'm not making you be here. Just going to throw that out there. This is completely optional.
All school worship's calling my name. Yeah.
I bet they'll record it and you can watch it in your free time.
All right. Thank you.
Bye, Lib.
Bye.
Okay, number 4, we already established that the slant asymptote was x plus 3, so I'm not going to go through that part again. So this is the factored form of the number 4. Nothing canceled, so I don't have any holes. So then I have 2 vertical asymptotes. One would be at -1, one is at +1. My x-intercepts I get by setting the numerator equal to 0. So when I set x squared equal to 0, that's just 0. When I set x plus 3 equal to 0, I get -3, 0 as my x-intercept. When I set, for y-intercept, when I set x equal to 0, I end up getting 0 over -1, which ends up just being 0, because 0 over anything, any number, is just 0. And then we already established that there are no holes because nothing canceled in the very beginning. So I'm going to scroll down, see if I can remember this. And I'm going to graph the things that I know. So my x-intercepts were at 0 and -3. My asymptotes were at -1, +1, and my slant asymptote was at x plus 3, which you notice actually goes through one of my x-intercepts. But slant asymptotes are kind of the same in that your graph can go through a slant asymptote or a horizontal, either one. They just can't go through vertical asymptotes. So if you have a dot on a vertical asymptote, then you've done something wrong, but they can go through slant or horizontal. So these are the only 2 points that I have. And from here, I really don't know what else I can do. One part of the graph that I can fill in without testing points, though, is this part right here. I know that it's going to be up here because there are going to be 3 parts of this graph. A part that's on the left side of the vertical asymptote, a part that's in the middle, and a part that's on the right side. So the part that's on the right side of my vertical asymptote is either going to be up here or down here, one of the 2. And I know for a fact that it cannot be here because it would have to go through the x-axis, which would mean I'd have to have another x-intercept. So I can go ahead and rule out that it's going to be a part of the graph down here because there's no other x-intercept. But for the parts of the graph in the middle and on the left, I'm going to have to test some points. So in the middle, I need 2 points that are between -1 and +1. So I'm going to use -1/2 and +1/2. and see if I can remember this. I think that's the original. So all I'm doing is plugging in to see if I have a positive or negative number. I don't care about the number itself. So when I plug in -1/2, I end up getting -1/2 squared becomes a positive. So positive times positive on top over positive times negative, which would mean negative on bottom. Positive on top, negative on bottom means overall a negative number. So it's going to be going down like this. Then for positive 1/2, I'd have positive on top, positive, positive, positive. I think, did I do that right? Oh, no, it'd be negative, sorry. Because 1/2 minus 1 would be a negative number. So that would be overall negative as well. So they'd both be going down like this. Then I need to figure out what it's doing on the left side. So I need two numbers, one that's on the left side of -3 and one that's on the right side. So I'm going to choose, let me just erase this. I'm going to choose -2 and -4. And that should tell me what it's doing on the left and the right, because it could be going up and down, could be both going up. I have no idea. So when I plug in -2, I end up getting positive on top and a negative times a negative would be positive on bottom. So I know it's going up and to the right. When I plug in -4, I get a negative on top over positive on the bottom. So it's going down. And I don't know, since you don't have the Desmos in front of you or a graphing calculator, it wouldn't matter if you drew it going down like that, going down like that. I don't even know honestly what it looks like. So as long as you have it going down in some form or fashion, then I'm good with that. And just proving that you solved it going down.
So if you always have like two vertical asymptotes, you're always going to have like three things on the graph.
You're always going to have one more part of the graph than you do vertical asymptotes. So if you have two vertical asymptotes, you have three parts of the graph. If you have one vertical asymptote, you have two parts of the graph.
Okay, thank you.
You're welcome.
Can you do number 20?
Uh-huh. Okay, number 20, I'm first going to factor this fraction to be x minus 2, x plus 1. And then I need to find my common denominator, which would end up being x minus 2, x plus 1. And then I need to figure out what my domain restrictions are. So x does not equal 2, x does not equal -1. Then I take each fraction, 1, 2, 3, and I multiply all three of them by the common denominator, which is x minus 2, x plus 1. So first fraction, they end up canceling out. So I just have x minus 8. Second fraction, the x minus 2's cancel out, so I'm left with 2x plus 1. If you go ahead and distribute it, it'd be 2x plus 2. And then the last fraction, the x plus 1's cancel out, and I'm left with 3x minus 2. So I'm going to go ahead and distribute that to be 3x minus 6. Then I'm going to simplify the left side. 3x minus 6 equals 3x minus 6. Okay, these are the same thing. If you even go ahead and keep solving, you end up getting 0 equals 0. Since this is a true statement, 0 does equal 0. That means any x, any number that you put in for x, any integer, would actually work. So I have all real numbers, or any solution would work, because it ended up that everything canceled out. However, the only two that I can't have are my two domain restrictions. So x cannot be 2, x cannot be -1. But if it ends up happening where everything cancels out and you have a true statement, then that becomes all real numbers, except whatever your domain restrictions were.
Thank you.
You're welcome. Y'all have other questions? Anybody? Okay, so for the test tomorrow, I haven't made it yet, so I don't have a ton of information, but I am going to still make it unlimited time to an extent. I'm not going to make it too long to where it should take you like 2 hours, but I will say it will easily be able to be finished in 90 minutes, but I'm not going to cut you off at that time because I want you to feel comfortable, but also don't take like 3 hours on it. I don't think it should take you that long. But if you just sit and stare, I don't think that's going to be productive either. You're not going to magically learn the answer. So you might just have to sit and stare. So that'll be the last test grade, the last grade. And then on Tuesday, which is the second to last day of class, we will do test corrections. And then, or I guess that's Monday. Monday will be test corrections. And then Wednesday will just be a day of like if anybody's missing anything, needs to catch up, get grades finalized, things like that. But yeah, pretty much winding down. So does anybody have any last minute questions before I let you guys go? Okay, well then I will see you guys tomorrow. First period is at 8, second period's at 11, or third period's at 11:30, and then fourth period is at 1:45. So I will see y'all tomorrow.
Thank you, Miss McKinley.
Bye.
Thank you.
Thank you.
Thank you.